So to answer the question, the journey of energy from a glucose molecule to ATP during respiration involves a series of steps. Basically, the glucose holds the energy within its chemical bonds through glycolysis. Glucose is broken down through the production to make a small amount of ATP. At the same time, high energy electrons and hydrogen ions are transferred to NADH, which is the electron carrier. If oxygen is prevented, pyruvate enters the mitochondria, where it goes through the citric acid cycle and oxidative phosphorylation in the citric acid cycle, and then the carbon dioxide is released. An electron carriers capture high energy electron. These carriers transfer electrons to the electron transport chain on the inner mitochondrial membrane, and the electron transport chain. The electron then travels through the protein complexes, created a protein gradient, and then that powers ATP synthesis through the ATP synthesis. The enzyme converts ADP to ATP using energy protein gradient. So also fermentation occurs when the oxygen is limited after glycolysis. Pyruvate is then converted into acids or kind of like alcohols in the cytoplasm. This regenerates the NAD plus from NADH, allowing glycolysis to continue producing small amount of ATP. Now, the ATP production is a little more efficient in respiration compared to the fermentation. Respiration can yield up to 36 through 38 ATP molecules from one glucose molecule due to the complete glucose oxidation in the citric acid cycle and also oxidative phosphorylation. In fermentation, the ATP production is limited to the net gain glycolysis, which is only 2 ATP molecule per glucose molecule. So basically, to wrap it up, during respiration, glucose energy is gradually released through glycolysis in the citric acid cycle and oxidative phosphorylation, with ATP producing being more efficient. In fermentation, only glycolysis occurs, leading to the production of acids or alcohol with limited ATP generation.